Good morning, everyone. Welcome to May 28th, 2020. I'm Lance French. No, I'm not Lance French. I'm Nick Foreman, Division Manager, Group Manager, and Senior Scientist for W&M Environmental, a division of Braun Intertech, and I would like to welcome you to our webinar on assessing your workers' exposures with industrial hygiene. As I alluded to before, the normal, silky, smooth baritone voice of W&M and Braun Intertech, Lance French, is missing his first webinar in 5 years, and I will be filling in. He is traveling to traveling cross country for a wedding. And Lance, if you're listening, I will try to do you justice, but we all know you're here with us in spirit, but please come back soon. Joining us today are our experts, Ms. Lori Siegelman, Mr. Conan Reed, and yours truly. I will be wearing two hats today, so thanks for joining us. Before we get started, I wanted to cover a few housekeeping items. If you have questions, please send them through the questionnaire or the comments tab on the GoToWebinar window. Miss Lydia Gross will be monitoring the chat and in general trying to keep us on track. If you have questions or if we don't get to your questions, we'll make sure that it gets into the right hands and we feed it to one of our experts for an answer and get you that as quick as possible. So unless I have messed something up royally, which I pressed record and it says stop recording, so I think I am recording. We are recording this webinar and it will be available to rewatch later on, and we will send that out with an email blast later on. So let's go ahead and jump right into it. To get us going, let's make sure, there we go. Our first expert is Miss Lori Siegelman. She's been a routine mainstay in our webinars. She's a certified industrial hygienist, a certified safety professional, a certified hazardous materials manager. You name it, she's got it at the end of her name. She's an old ag, sorry, I didn't mean to imply an old ag. That's a term of endearment for Aggies. But she's also got a Master's of Science and a Master's of Public Health, and she's been with W&M for over 12 years now. So thank you for joining us, Lori.
Good morning.
Our next panelist slash expert is Conan Reed, a graduate safety practitioner. He's been with us for about 4.5 years and studied at Murray State. And I know the whole Kentucky area missed not having the horse races and missed not having March Madness. For the Aggies in the group, we didn't care about March Madness because we weren't making it anyway, but I know that was hard on Conan. So welcome and thanks for joining us, Conan.
Thank you.
Right. And then I'm Nick Foreman. I will be co-hosting or hosting and co-experting, I guess, as much as possible. I've been with W&M and Braun for about 12 years, a little over that, and I've got a BS in biology from A&M and a Master's of Public Health from A&M. So with no further ado, let's go ahead and get started and jump into the webinar. Lori, would you like to take it away?
Sure.
All right.
Thanks. So what you see on the screen is basically just the formal definition of industrial hygiene. So it's a science of protecting workers, protecting the health and safety of the people in the community as well. And it covers a broad range of items. And more, here I'm advancing my slides on my computer, but
oh, sorry. Well, so before we go on to the next slide, then I know there's some some confusion sometimes on what industrial hygiene is versus the overall what is worker safety. Is there a clean definition or a clean break somewhere?
Worker safety is going to cover the whole gambit of industrial hygiene. Is just a part of that. So if you can think about worker safety, you may have people that are working from high levels of equipment that have a fall hazard, or they're working with some chemicals where they have a potential for exposure. So you're trying to protect those workers, but the industrial hygiene portion is looking at maybe those stressors, the chemicals, or some other type of hazard that they may be exposed to.
Gotcha. Thank you. All right, now we'll advance the slides, Lori.
Right, okay. Okay, yes, thank you.
Mm-hmm.
So industrial hygiene, kind of as Conan explained, is more of a subset or part of an overall safety and health program where you're really looking at stressors, environmental conditions. You want to be able to first recognize or evaluate your workplace and identify these potential hazards and conditions. Then you would use some environmental monitoring analytical methods, maybe some modeling to determine the extent of a worker exposure. And then finally, if you have some unacceptable risk to your organization, then you want to put in some controls if you don't already have some controls in place. So basically just a worksite analysis to identify which jobs, which processes or tasks or areas where there might be a potential hazard from an environmental condition or a stressor like noise or heat. And then this slide is more just a visual representation of that same thing, just the three major steps in industrial hygiene or an IH assessment or exposure evaluation, whatever terminology. Sometimes it's interchangeable unless you want to get into the fine nitty-gritty details of definitions and terminology. But basically, recognize the hazard first. Sometimes hazards aren't always readily identifiable. Evaluate that hazard. Determine what risk level you're at and whether or not you need to control the hazard in order to keep your folks safe.
Yeah, and then what you do, what kind of controls you implement, and in an ideal world, everyone's exposure would be below the action levels, but it's not always the case. So
exactly.
All right, jumping through, we'll go through this process here. The way it's broken out now is following the steps to the IH assessment. So the first one is hazard recognition.
So you're going to have to recognize what types of stressors that your employees may be exposed to. They can be either a chemical hazard or it could be a physical hazard. When we talk about chemical hazards, we're looking at gases, vapors, fumes, dust, mist, and there are some sometimes confusion of what a fume or a dust or a smoke and a mist and a gas is. And so when you're looking at those stressors, you may have welding processes or something that's heating something up. That's going to be fumes that are coming off of that. A lot of times you hear people interchange the word fumes for smoke or fumes for like a gas or a vapor that's coming off. And really what they're using fumes in general, but fumes are really that metal fume is what we're talking about for welding. And you may have other things that are vapors coming off that are evaporating off of a dip tank or something like that, where employees are working with those chemicals, and you have those chemical vapors evaporating off. Physical hazards, we have radiation, we have noise. You may have a heat stress scenario, or it could be an ergonomic type hazard where employees are working and doing routine tasks that are just put them in
repetitive,
very repetitive, right. or it may be a vibration type hazard that they're working around. So this slide is showing just kind of a breakdown of common industrial hygiene hazards by industry type, and one of the ones that I point out here is ever since the Silica standard came out, we've seen this a lot, and you have a lot of different industries out there where you have a potential for exposure to airborne silica, and the standard has reduced that exposure limit so much that it's very hard to even meet the guidelines for it. So to keep your employees from getting exposed to silica, there's things that you can do as far as control measures or PPE, but you also need to know kind of what your levels are, get kind of some baselines and some ideas of what exposures there are. So this kind of helps looking, you can see that silica could be in construction, from working around cutting, or if they're grinding or chipping concrete work, or if they're drilling. And the construction standard has some nice things that they implemented to help control those exposures. If you're going to use these tables, you can use some engineering controls with wet methods, and you don't have to do the monitoring as you do into the general industry standard for the silica. And then in manufacturing, you may have employees that are using products that contain silica. There's, in jewelry making and other manufacturing processes, there's silica that's in some of the investment materials, but it's a lot of times that stuff is very fine and it gets airborne very easily, and it's hard to control those. And then, of course, in mining, you can imagine that there's a lot of silica, or it could be coal dust or other respirable particulates that are in there. If you're doing concrete production, you've got obviously dust, silica, and and noise and all of these. And then in some steel industries, you've got still exposure to potentially silica, and you have the metal fumes, some dust, and then oil and gas. I believe that standard is going to kick into effect soon for the silica standard, but in fracking industry, you have potential for exposure to silica and dust in that, and a lot of these, you also have that noise exposure in pretty much all of this. Now, one of the things that to point out here, if you see in the public warehousing, if you got employees that are operating fork trucks, you have a potential for carbon monoxide type exposures in those buildings. If you're using, say, propane powered forklifts, or if you're using a diesel powered truck.
Yeah. So if your forklift drivers are seeming abnormally slow that day, maybe you have a carbon monoxide leak instead of they're just not participating as well as they normally would. Gotcha. So the silica standard is obviously kind of been a game changer here lately, but just in case you're not really familiar with it, the silica comes from elements that you use. It's in sand, sandstone, granite, all of those things that you might be manipulating during construction projects, or it's in chalk and limestone and all that kind of stuff. So if you're dealing with sand, cement, limestone, all that kind of stuff, it's very possible that you have a silica exposure.
Yeah, and the granite, when you mention granite, there's also the naturally occurring radioactive material that's present in the granite as well. It's been a little bit of a buzz in the radiation safety world for the past few years, and that exposure is not, it's well known in some circles, but in your general workforce seems to be not as well understood.
That's one of the reasons we haven't upgraded to granite countertops.
You're cutting on
That's
that
right.
and breathing in those radioactive particles. So.
That's right.
So here's some common airborne contaminants. We have dust. This could be an airborne solid. Particles generally from the 0.1 to 25 microns. You have silica, asbestos, could be a lead dust, or just general dust. And there's some exposure limits based on the type of dust. There may be a specific dust that has an exposure limit, but as far as OSHA exposure limits for dust in general, there's one for a respirable fraction of that, and then one for a total particulate of that dust. Mist, suspended air droplets, could be an oil mist, acid mist, pesticide mist, could be some mist from painting, such as the guy doing here, as well as he's also painting, spraying and creating some kind of solvent vapors in the air. Could be some diisocyanates or other types of VOCs that could be emitted during that spray painting operation. As for fumes, we talked about the welding fumes. These are solid particles. Could be a lead oxide fume, iron oxide, copper fume, and other types of metal fumes generated from welding processes. And then gases, we have CO. We talked about the carbon monoxide is a pretty common one. Hydrogen sulfide, chlorine gas, just depends on what the industry is where that exposure and what type of chemical you may be having.
And one thing that's not on the list here that you might want to mention is we've done a fair amount of sampling or analysis evaluation for metalworking fluids as well, which is a little different. So if you have a metalworking operation, metal fabrication, and you're using the CNC machines or metalworking fluid in that, then that might be a concern you want to consider.
And some of those, especially with the metalworking fluids, there are some biologicals that can be with that, as well as the kind of the oil mist or the metalworking fluid that gets generated. You may have exposures to some biologicals in that metalworking fluid, like endotoxins and things
And normally you can tell when that stuff goes bad because it smells pretty darn bad.
Yeah.
Your
And your
metalworking
employee
fluid
complaints will go way up once that happens. So
yeah, it doesn't look like milk anymore. It looks pretty.
Right. Well, and dependent on the shop, that might, some people, when you're so used to a smell or a situation, then it could be they have a situation and they're not really recognizing it because that's just the way it
Right.
is at that
Yeah.
particular shop. So something to keep in mind.
Yeah, and they make bacteria stats and things that they can put into those to control that bacteria levels that grow in that working.
That also reduces their cost overall, their operating costs too, because it's more quality. They don't have to replace it as often.
Mm-hmm. Some the exposures we talked about, they have toxic effects. It could be a respiratory irritant, a skin irritant, or an asphyxiant. As far as the respiratory irritants, it could be something that's like the phosgene gas, which is smells like the hay. They hear that it's probably a World War I or World War II type poster that was here. For our example, skin irritants, things that could either be that gets on your skin. A lot of these you'll see on a HAZCOM label will have like a little exclamation point on it, where that it could cause some kind of irritating effect and gets on your skin, cause irritation, maybe some dermatitis later. Then we have chemicals such as methane, ethane, hydrogen, which are simple asphyxiants, and then you have chemical asphyxiants, which attach to your blood cells and prevent the oxygen binding with your blood. So those are carbon monoxide, your hydrogen cyanide, nitrobenzene, hydrogen sulfide are all chemical type asphyxiants, whereas the carbon dioxide would be a simple asphyxiant, which displaces the oxygen out.
Yeah, and this phosgene, this little poster reminds me also that it's not always very straightforward to identify your chemical hazards and the toxic effects. If you're just looking at what chemicals you're using and then the safety data sheets, you also have to consider maybe how those interact in secondary emissions or secondary interactions between some things. For instance, in reference to the phosgene, there is a situation if you're welding. Argon shielded electric arc welding, in particular, is one area where if you use TCE, for instance, to clean, right, and then you're going to weld a piece of equipment or whatever you're welding on, and you have some airborne TCE and airborne concentrations, there is a potential for some interaction to go on between that, and then the decomposition products of the TCE will lead to phosgene and pulmonary edema and some issues of the welder or whomever is in the area. So not always straightforward.
Right. Yeah. And another example of that is we got a call from a client probably 2 months ago saying that when they go in and they clean their mixing tanks, there's one particular mixing tank in general that every time they treat that waste, both of the females back in that group, they both come back with a very uncomfortable, upset stomach type feeling. And all the men back there, they don't have that feeling. So we've gone through and looked through SDSs. We've looked through ToxFacts to see if we can't find some sort of association with the SDSs they gave us to see if there's some link between upset stomach, gaseous, all that kind of stuff. And we haven't been able to identify that yet. So we're still in that first phase of identifying what the hazard is and why we're seeing the toxic effect there. So we're still in progress, but we're working on it.
Yeah, and you assume there's a hazard there, but there may not be. But that's one of the more interesting aspects of industrial hygiene, and what we do is getting to kind of go in, evaluate, and try to help people identify if there is a hazard at all, and if there is a hazard, then quantify that or find some control. So we're still in those initial phases to try and evaluate to see if there's a hazard, maybe this unknown, as we were talking about, not readily apparent hazard that could be causing these health effects.
Yeah, and what you said reminds me. Years ago, I did a industrial hygiene study at a facility that did some automotive seat manufacturing, and they had a system that was a carousel where it put some foam on the seats and molded that those seats. And one of the constituents that they use, they had some employees that were working with it, and typically it had a nice ventilation system that was hooked up. But I guess they had made some changes to that carousel, and they didn't get the ventilation put back on there. So the employees that were working with that, one of them started having vision problems where his sight had blue haziness in his eyes, and it was the chemical. He came to him, and basically they found out that, hey, he's getting overexposed to this. It was in the SDS that showed, hey, this is one of the effects of that exposure.
Interesting.
Yeah.
Yeah. So those toxic effects could be the anesthetic or a narcotic type effect, where you have some numbness or dizziness, and those could be from ethylene or ethyl ethers, acetylene. You have systemic poisons. These are types of poisons that affect a part of your body that's away from where your actual exposure site may have been. Could be something that affects your liver if you inhale it, or maybe it has something that affects your kidneys. These are like carbon disulfide, methyl alcohols, tetraethyl lead, mercury, cadmium, manganese. These are all metallic systemic poisons there. Could be a chemical carcinogen, where it's a potential cancer causing agent, or it could be something that scars your lungs after you inhale those dusts. It could be like asbestos or silica or coal, and these are all things that get stuck in your lungs down deep in there, and then your body trying to remove those substances ends up scarring your lungs.
Oh, your little alveolar sacs get jammed up and end up bursting. That's all fun stuff, right?
Probably not for the person.
No.
Well, it was okay. I wasn't being serious.
Interesting, though.
Some other sources of contaminants could be, processes that we talked about, the grinding, cutting. These can generate dust, as well as could be a metal dust if they're grinding on, say, metal for in a welding fabrication shop. And some of those dusts, the metal dusts, do have exposure limits that may be less than what the total exposure limit for regular dust is. So you just want to identify what that particular dust or metal is, so you determine whether or not you need to reduce those limits for that. Could be a process that involves combustion, or we talked about the metals releasing fumes from welding. Could be liquid spray processing, spray painting or degreasing processes, or somebody working around a pickling or etch line that is treating metal surfaces that could be breathing in either a caustic or an acid type vapor that's coming off.
Right. Yeah. And sometimes in the grinding and sanding world, if you're grinding and sanding something that's been painted or treated or surface coating, you've got, other things to consider as well. Chromium, lead, heavy metals that could have been in the paint or the coating.
Sure.
The physical hazards, these noise, we have temperature, heat stress, could be a vibration hazard, it could be radiation, or it could be an ergonomic hazard, which kind of correlates with the vibration hazards.
Yeah, these are a little bit easier, in my opinion anyway, to identify. There's not as many different things that can cause your body as much stress as maybe an unknown chemical, or having to go do that investigation. A lot of times you can, if you're having to yell to the person next to you, it's a lot easier to know that you have a noise issue. Or if you walk into a building and you're just drenching with sweat because it's humid and nasty and gross, it's a lot easier to say, okay, we need to do something to address our heat stress.
Much more obvious. And the physical hazards to me is more closely interlinked with the traditional safety role. So.
Okay, so now we're making some assumptions here for this slideshow. We've assumed we've already gone through the assessment and the evaluation, and we've identified what we think the hazard is, and then now we have to go through and evaluate that. And Lori's going to walk us through that process.
Right, right. So you want to do a risk assessment or a hazard evaluation, as I said. There's a lot of different terminology, but basically once you have done your basic workplace assessment and tried to identify all your jobs and processes and where your hazards and your potential exposures might be, then you want to quantify that somehow, either qualitatively or quantitatively. So you could potentially do an exposure assessment or an initial risk assessment using some modeling. There's several software tools out there, Excel spreadsheets that have been designed, where you plug in certain data, or you just qualitatively stand back and look and say, hey, they're using a chemical. You consider the chemical's toxicity. So you can look at the data sheet. You can consider what is the exposure limit, if an exposure limit has been set. So what's the toxicity of the chemical? Are they using it in large quantities? Are they like spray applying it all day long, kind of swimming in this mist of chemical? Or are they dabbing a little bit on a little wipe and wiping a piece of equipment clean? And maybe they do this all day, or maybe they do it for just an hour. So you need to first identify. Once you do that, then quantify what that risk level is or what the exposure potential is. And you might want to ask, well, why would you want to model it when you can just sample it? There's a lot of good reasons to model or to do this qualitative assessment first. First, do you have a problem that requires sampling? Maybe you want to do some qualitative assessment, document that you've done that, and the information that you have, it's just well known and obvious that you don't have a potential issue that could cause an exposure over say 1% or 10% of your exposure limit. So you're not going to do sampling. Or maybe you have a very mature ESH management system where you do new process reviews and new chemical reviews before you have the person doing seats manufacturing and seeing blue lights, right? So you evaluate that process first, and you want to maybe do some modeling and some qualitative risk assessment or hazard evaluation before you implement that process. And which brings us to another method you could possibly use. Conan, you want to explain this?
So you could do some workplace observations where you identify those, like Lori said, you identify what that potential health hazard is, what chemical it is, and then you're looking to determine what employees could be exposed or what they're doing. And you can use some modeling in the little formula here that basically determines really kind of if you have a potential issue based on what you're using, the exposure limit, how much it is, and what those that physical hazard or physical nature of that chemical is. So you can do this, and it gives you a nice little generation of potential exposure, or what that evaporation of that could produce in the air.
Yeah, and assuming you've got pretty good data, I assume that this is probably a fairly conservative estimate, and rather being on the low side where you might be getting a little bit of trouble.
Yeah, and this can really help you if you're going forward you're looking maybe at a new chemical or a new process, and you're saying, well, do we need to then have some kind of ventilation? Do we need to put this process in an area where we've got, good air changes and dilution ventilation or exhaust ventilation? What needs to happen? And this can help you determine that. So if you are, going to bring this chemical in, or if you're starting a new process, what control measures you may need to bring in before you just get started with you doing it.
Right. Yeah. And I did something very similar to this for a client years ago. Now I just remembered where they were installing a new nickel plating line or something to that effect, and they needed some sort of calculations and ideas of what the concentrations would be so they could design their ventilation system rather than waiting until after the fact and say, oh, we need ventilation for this.
Yeah.
And crossing your fingers and hoping it works.
Right.
Hope they can run that duct work out of this room that we.
That's right.
Exactly. So other reasons you might want to do an industrial hygiene assessment, other than, say, for a new process that you're going to install or a new chemical you're going to start using. Maybe you want to just determine worker exposure. The most obvious thing is, hey, we're doing this welding thing, or we're doing this chemical dip tank thing. What is our worker exposure? We certainly have the potential exposure there. We want to check it. Maybe you've now installed your nickel plating line or your dip tank, and you've put the ventilation in the way that you have anticipated that will control, but now you want to do like a pre-startup review. And this is good for any new process. If you put in a control, you want to see, is the control effective like you imagined it would be? Is it installed correctly? Is it working properly? Is it set up properly? Does it pull, how many ever liters per minute or feet per minute, face velocity, whatever it is? So you want to do an industrial hygiene assessment to check that. And then finally, maybe you just want to establish baseline data across the board. You've identified all of these different hazards. You feel like you're in an okay place. But you want to have that baseline data on hand to satisfy your compliance requirement, audit requirement, maybe your customers do audits or your corporate requirements.
Yeah. And when you're evaluating those controls, we can do an IH assessment of those a ventilation assessment of that equipment. And it doesn't mean just because it didn't, your ventilation equipment didn't meet design guidelines, doesn't mean you're going to have an overexposure, an exposure issue. But, that may be, okay, so do we now do some testing to determine if we do have a potential exposure issue, or do we just spend a bunch of money and try to upgrade our ventilation? So you want to determine what that can help you determine if you're going to actually need to.
Right, and it may not be working as you expected, but still for working. Your purposes, it's working just fine. And then, so once you decide that, okay, for whatever reason now you're going to do an exposure assessment or industrial hygiene sampling, how do you go about doing that? So typically, you're going to do a personal air sampling. You put the air sample device or filter, cartridge, or whatever on the person itself near the breathing zone on the lapel or in the area of the breathing zone. Or you can do an area air sample, which the area air sample, you can't really compare that directly with an exposure limit and say, oh, we're above or below, but it does give you an idea, maybe a worst case scenario, if a person were to be completely static and stay in this spot all day long, they have the potential. Or you're looking at establishing some gradients of exposure. Noise, this is very common where you do just a survey, not necessarily noise dosimetry on individuals, but you want to establish a gradient to see how quickly your noise levels fall off common areas or the adjacent work area you're interested in assessing. Yeah,
and that can help you determine how long somebody would be working in that area before they would kick into an action level or an overexposure scenario.
Okay, and then, so now you're going to sample, you're going to do some personal sampling, maybe you're going to add some area samples to that. It's very important to develop a good sampling strategy. You want to make sure that your selection of individuals and or areas or whatever it is going to be representative of the exposures you're trying to quantify or to evaluate. So choosing which employees, how many samples to take, how many employees, do you do it day shift, night shift, half a day, a full day, all of those things need to be considered. And there's not just an easy,
Wouldn't that
hey,
be nice,
let's
right?
do 25% of, which is one way. But there are several different methods out there. If you're doing it, you want to be aware of why you're doing it. Is it strictly compliance and you're trying to satisfy OSHA? Then you can pick one representative worker in an area or doing this job, and they're the worst case or have the maximum exposure, and do that, and that would satisfy OSHA's requirement in some cases. In other cases, if you're doing like lead or silica, whether there's a specific standard, there might be, or asbestos, there might be a specific requirement to do more individuals. But for the most part, you could just choose one. But generally, there's different ways to do it. And I've been doing this so long now, I really could look at an individual or group of processes and tasks and pretty much try and get a good representative sampling scheme put together for the client that both captures the exposure adequately for their purposes, demonstrates their compliance with the standard, and also at the same time will get a good idea of what their real risk is, and then also it's cost effective for the client. If you wanted to get a really good idea of the risk and you have hundreds of employees, then that becomes much more complicated, or can be much more complicated. So anyway, so that's the next step. Develop your sampling strategy based on what your purpose of the sampling is and all of the other.
So Lori, we have an audience question.
Okay.
They're asking, do you have any examples on a poor sampling strategy?
On a what?
Any examples of a poor sampling strategy?
A poor sampling strategy. Let me think. Can you think of one offhand?
I can think of dozens of scenarios where you're picking somebody that may not be working with, like he's not a representative of the sampling group. So you've got several people doing a process, right? You're trying to, maybe they're welding and you're wanting to capture maybe hexavalent chromium. So you're like, okay, I'm going to get my welders. We're going to sample a couple of welders here. And then the guys that you sample are only welding on stainless steel or some chrome content steel for just a portion of the shift, while the rest of the people are doing it all day long. So your representative sample isn't necessarily your representative exposure group. So, right. Or it could be something similar to that, or
and
or somebody leaves early and you didn't.
I've had that happen before. So the whole purpose of the sampling was to hex chrome in the paint. And so we set up the sampling, we got 2 or 3 different painters, and then we get there that day and start sampling. And I think the end of the day, they said, oh, we're not using that paint today.
That's happened many times.
Or I got pulled off on to help with another project.
And I'm not sure that's really answering the question, though, that's the sampling strategy itself, I think was okay. It was the realistic situation, the lack of communication, and the lack of understanding maybe with the client, that they weren't doing that today, and the ESH manager didn't know because of the communication issues. But poor sampling strategy would be if you just, maybe you're very cost conscious and you just want to do 1 employee or 2 employees sampled, and you have a wide variation in exposures because you have different setups and different behaviors and techniques of doing something that from one employee to the other is going to vary your exposure potential drastically, and you've got like 20 employees and you only sample 1, then that's a poor sampling strategy. Your chance for error, your error rate is going to be much higher there. So you will not have a very good chance of catching that most exposed employee if you've got several employees doing the job where the variation in exposure has the potential to be a wide variation, and you only sample a very few people. That would be a poor sampling strategy.
Thanks, Lori.
Okay, then I think we've already covered some of this, but still, looking at the sampling strategy, you want to consider employees that are closest to the source, like the welder who's actually welding, or a person that's sitting in an adjacent work area where the airflow in the area is from somebody's working with a chemical or generating some kind of airborne contaminant, and it's being carried to the adjacent work area, and you don't evaluate that at all. Say it's a highly toxic chemical. Anyway, so you want to look at employees closest to the work where the hazard is. What are the work habits? Employee mobility, that goes to that variability and that variation and exposure potential there. If you have a highly mobile workforce, your air movement patterns and different work habits, as I said, if you have that variation, you want to do more employees, more sampling.
So I think you've pretty much covered most everything on this slide already. Are you okay skipping it?
I will just mention this, the exposure groups, 6 to 10 employees sampled for each group is more of a, if your purpose is to do a true risk characterization and you have fairly large work group. I mean, if you only have 10 employees, period, or 2 employees that are doing this job, obviously you're not going to sample 6 of them. You know, or 100% of them. You could, if you have a very small group, 2 or 3 or 4 people, and they're all doing the same job, then you could do 100% of the sampling. But this is more of a, if you're doing a more industrial hygiene risk characterization and you have a large workforce, you might want to do 6 to 10 employees per group, per exposure group, and maybe not all at once. Maybe you want to do, you know, a group a month or once a quarter or something like that. Basically, this kind of summarizes what we've been talking about. First, you want to look to see if what are your hazards, and this is speaking more to chemical hazards, specifically airborne chemical hazards. Do you have a chemical released into the air? Then yes, you have a potential for employee exposure. Then you kind of stand back and do that qualitative look to see, or maybe quantitative. This is where your IH exposure assessment would come in. Is an employee exposed above the action level or above some percentage of the exposure limit? Say it doesn't have a set action level, but you look at an occupational exposure limit, whether that's the PEL that's set by OSHA or a NIOSH REL or whatever. Are they exposed above a certain percent? Say if they're exposed above 25% or above 50%, then you want to make some assumptions. Is that exposure an acceptable risk? And if not, then maybe you want to install some controls. But depending on all of that, then if the exposure is above what you consider to be potential exposure of concern, you want to get more of a better handle on it or characterize the risk better. You do industrial hygiene sampling or monitoring, quantify that. Obviously, if it's above a regulatory exposure limit, you want to notify those employees, or even if it's not above the limit, it's always good to communicate with your employees about what their exposure is and is it safe, is it not safe, your hazard communication program. And then also based on your result of the sampling and the result of the exposure, then you have some frequency of resampling. From a regulatory standpoint, you're not necessarily required to go back and resample in a specific period of time, except under certain circumstances for certain chemicals. But generally, if the higher you are closer to your occupational exposure limit, even if you're not over, that would increase the recommended frequency of sampling.
Right. And some chemicals, as Lori was saying, like silica, hexavalent chromium, and other chemicals have a specific standard for them. There are some action levels and some resampling requirements based on what those initial exposures may be. So you may be kicked into where you're having to develop a regulated area for that chemical and then resample on a quarterly basis or even a semi-annual basis, depending on what those exposures are.
So I think we already covered this too. I know
we did.
This is prettier than the last slide, so I wish we would have done this one. But yeah, we've already covered this, the types of sampling, so we'll go ahead and skip on to the next one. So the next section of this is kind of a free-for-all for the three of us here. Yeah, we covered the types of sampling. So, but this is okay. We've gone through. We've identified the hazard. We have now evaluated it, and now we're to the point on what do we do, right? So if you have exposures that are below the action levels or below the criteria, then there's not a whole lot you have to do. Document it. We put together a report with all of our work here, and that way you have a letter that if you ever were to get inspected or you have a complaint, say, hey, we've already evaluated it, and we've taken that into consideration. But what happens if you have an exceedance, right? So there's the old hierarchy of control, right? And most of us have seen this. We've been bludgeoned with it. We've seen it over and over again. Every time you look it up, there's a different version out there. There's a there's a 3-tiered version, there's a 4-tiered version, there's a 5-tiered version, whatever it is. But the principles are all basically the same, right? So the best thing you can do is prevent the hazard, right? If there's a way that you can design it out or engineer it out from the get-go, that's a good way to do it. Let me get to that slide first. There we go. Okay. So one of the ways you can do that is actually design the hazard out of the process, right? So if you know that you're going to have a compressor station that's going to be vibrating like heck and always doing that, if you can install it in a way that has the shock absorbing, the shock absorbers, whatever they're called.
Some dampeners on the.
There you go. Thank you. Yeah. On there to reduce the vibration and get that from the get-go. That's a way to do it. Another thing that you can do is you can take, if you know you are using a hazardous chemical in your process or somewhere in your facility as part of your processes, then you can try to find a substitute for it. Obviously, if you're using a solvent like a PERC or a TCE, one of those, you can always try to find a solvent that's less hazardous, right? So as a general rule of thumb here, if you have a high hazard chemical and you can go to a low hazard chemical, that's a good idea and a good practice.
Yeah, and I just wanted to add too, it's not necessarily that you're exceeding any exposure limit. If you're getting 50% or 20, even 25%, depending on your risk tolerance, you still want to control the hazard as much as you can.
Sure. Right.
As feasible as you, if it's technically and financially feasible, even if you just have your 10% of the occupational exposure limit or 25%, it's still good to try and control that exposure to the extent that you possibly can. Through prevention, as you said, the first step, maybe we can just eliminate the exposure through substitution or elimination to start with.
Yeah, and you could, especially with noise, you can find equipment that may be much quieter, like you said. With compressors, there's scroll compressors that are much quieter than the centrifugal compressors that we're all used to. However, there is a cost associated with that, so
right.
That does become a feasibility depending on your operation.
Yeah. So one of the things that I always come back to whenever I look at the hierarchy of controls is, one, if you can eliminate or substitute the hazard out completely, obviously that takes a lot of the risk out, if not all of the risk out, because you've gotten rid of that hazard, right? But one thing it also takes out of consideration is the higher you are up on the hierarchy, higher up you are on the hierarchy. That's a mouthful. The higher you are up on the hierarchy, the less employee interaction or responsibility that they have. So as you move down to the next level and the next level and the next level, they have more responsibility that they have to remember to do. When you get down to administrative controls and when we get down to PPE, they have to remember to do all that stuff. If you engineer it out or you completely eliminate the hazard, then there's not really a whole lot of onus on the employee.
Right. There's a lot more human error, potential for human error, or maybe not even error, but just they're going to ignore whatever.
That never happens.
As you get down. Well, they want to do the job and they want to do it well. And that's
the way we've always done it, right?
This thing over here you're making them do, it takes longer.
Yeah.
Or it's uncomfortable.
That's right. So the next rung on the hierarchy of controls is the engineering controls. And what this sets out to do is you can't always eliminate the hazard. You can't always completely substitute it out, but you can find ways to limit the hazard by installing, ventilation, exhaust, automation. It's more and more popular now. Instead of having, an employee pick up that drum or not, that canister of methyl ethyl death, they'll have an actual robot go and do that and stuff. So you're eliminating that potential hazard there. Same thing on the physical hazards. You can do shielding for radiation. You can put up a whole bunch of, it looks like that's lead bricks there to keep you safe from radiation. You can put some noise insulation in and some dampening, and just to kind of redesign the process and make sure that you're doing it as safely as you possibly can. The administrative controls, this is something that typically is passed down from the top down to the employees, but it's always a good idea to have the employee feedback when you're doing all this, right? So what this gets at is making sure that the employee follows certain procedures or guidelines that are passed down to them. Worker rotation. If you're doing a repetitive motion activity and you're on the same line all day long every day, you're going to end up with back problems or knee problems, whatever it is that the hazard is there. But if you rotate along the line, go do different jobs throughout the day, you're not going to have that normal wear and tear that you would have if you do it all day long. Same thing like if you have an area of your plant that's extremely noisy, then you want to make sure that area is restricted to those employees that need to be in there, that have the proper PPE, and can get in there. And then standard operating procedures are always a good idea whenever you have hazardous chemicals and that kind of stuff in the workplace.
So one thing to point out here is that some standards, such as noise, worker rotation doesn't get you out of the standard. So if you have exposure, you can't rotate out and substitute a bunch of different workers in there to reduce those, because now you're just adding the exposure to unnecessarily to more people. So it doesn't necessarily get you out of the standard. If there is a standard specific chemical involved, you can't do that, but it may help reduce some exposures, but you still would need to do some monitoring and that sort of thing. And it may still have to have a regulated area or put people in a program with training and other things.
Sure. And then the bottom rung on the hierarchy of controls is the personal protective equipment. It's a lot of times the easiest to do quickly. A lot of times it's the cheapest to do quickly, but it adds up over time. I mean, if you think about buying gloves leather gloves for 50 employees over and over and over again all year long, then maybe you should invest in an engineering control further up the line, or administrative control that they can follow, that they don't necessarily need to wear the gloves every time they do the activity or whatever it is. But this is, all the normal PPE. You've got respiratory protection, cooling vest for heat stress. That's something that we've really kind of started using here at W&M and Braun here lately. As the technology's gotten a lot better. For a while, it was just, wet down this cool magic rag and you'd be cool after that. And we didn't find that worked very well. But now with the new technologies, it's getting better and better. So the PPE, again, that puts the onus back on the employee. It makes them know how to use their PPE. It makes them have to remember to use the PPE, make them put it on, make them don it correctly. And then, Conan, you're looking at me. I know you're going to say, hey, if you've got respiratory protection, you've got to have a respiratory protection plan. That's a whole nother level of difficulty there. So it doesn't get you out of, the standards, and it doesn't, always work, but it is, as a worst case scenario, as a last ditch effort, is something that you can do. And it does work. It's just, it puts all the onus back on the employee. So I think we're almost done. So, as far as the OSHA technical manual here, we're not going to obviously talk about it much, but that we use that a lot for the references in the slides. So it's a good resource there for you. This is our contact information. Obviously, this will be mailed out and part of the slideshow whenever we send it out. I do know we have one more question that just popped up. When we were talking about the sampling strategy, there was a question on, well, so how often do you have to resample, or is there a set? Should it be done quarterly? Should it be done yearly? Do y'all have I know it's probably going to be, it varies, but do y'all have a good answer for that?
Yeah, and it does. It varies.
I knew it.
So if you fall under a particular standard like silica or lead or whatever, and you have an exceedance, of the action level of an action level or an exposure limit, then the regulatory language will tell you you have to sample quarterly or semi-annually or whatever the case is. So beyond that, just good practice is going to be, are you just best practice? If you're well below the exposure limit, whichever one you've chosen to compare to, then maybe once every 2 years, once every 3 years, a ballpark. If you're, say, 25% of the exposure limit, maybe you want to do that more frequently, once a year, once every 2 years, instead of 2 or 3. If you're closer to the exposure limit, then yeah, you want to do more frequently, and you want to invest in controls. At that point, you want to be putting into some controls and then resampling. Maybe 6 months later or 3 months later, is the control effective or not? If it is, and now you're lower still, maybe you're 10% now of the OEL, you can back off that sampling frequency. Conan?
Right, and if you've changed chemicals, you've increased production, you've added some new processes, then you may want to bring in and do some additional sampling. Maybe you added some equipment and you sampled for noise and you didn't have a problem, but now you've added a new compressor, a new piece of equipment that could potentially add to that. So then you don't necessarily need to do noise dosimetry. You could do a sound level survey and determine if you've increased your noise levels in the facility.
Right.
Yeah. Okay. Well, I've also heard too that sometimes if you have an insurance company, or if your company has an insurance company, they will make you do it every year or every quarter, whatever it is, until they're comfortable. And then obviously that there's a little bit of variability there.
Sure. Yeah.
So the short answer to that is it depends, but we can always rationalize it there with you guys too. So. Thank you guys for attending today. We know we went a little bit long on the presentation side. Do we have any questions? Any more questions?
Well, we're almost out of time, so I think that if we can just get back to anyone who has questions, if we didn't get to you, we'll have our experts reach out to you through email to answer any of those questions we didn't get to.
Okay. Just a reminder, our next webinar is Vapor Intrusion Challenges and Trends. This is June 25th. So next month, about 4 weeks from now, it rolls around like clockwork. Again, that's vapor intrusion, and that's going to be with Frank Clark and Chris Thompson. So make sure you go to our website, you register. I think there's the opportunity to register for the next 4 or 5 if you really enjoy yourself and have a good time. I promise you, Lance will be back next time. You don't have to listen to me do all the intro and everything. So I appreciate it.
And the vapor intrusion one is kind of an industrial hygiene, but it moves over to a different level. So now we're no longer talking about workplace exposure as compared to exposure limits. So this is a good, if you've got people that used to work in an area where they were exposed. Now you fell under a HAZCOM standard, you fell under some industrial hygiene, but now you've eliminated that process. Maybe you've contaminated some building
underground water,
and now you've got exposures now from vapors that are coming up. So it'll be a good one to sit in on that one.
Sure. So thank you, everyone. I appreciate it, and we will talk to you next time. Thank you.